Hello. Today we're starting a new chapter called Algorithms. This is our first activity called the right-hand rule in the Algorithms chapter of Code 1. So just a reminder, an algorithm is really just a step-by-step set of instructions that when followed from beginning to end will solve a particular problem or perform a certain task. Okay, so that's what an algorithm is, and we've been doing algorithms all along. We've been talking about algorithms. We've been using our natural language to talk about algorithms. Walk 3 blocks down First Street, and when you get to the stoplight, take a left, travel 2 blocks down Main, and the first store on your right is Fred's hardware store, something like that. Okay, that's an algorithm in natural language. We've also written a bunch of algorithms in Swift so far to solve certain puzzles, and we're going to do another one here today. But what we haven't talked about yet is this idea of something called pseudocode, which kind of bridges the gap between natural language and a what we call a high-level language, computer language like Swift. This is somewhere in between. It looks a little bit like a high-level computer language, but it can also be written a lot like our natural language. So we'll look at an example of some pseudocode here in a minute. But right now, let's look at what we need to do in this puzzle. So the goal here says we should use the right-hand rule algorithm to navigate around walls. And we're going to run this puzzle a few times here to look at these walls. First, let's take a look at it here. So it looks like Byte needs to get, this one could be tricky. We've got some gems that are located in between these walls, and the walls are of different lengths. Okay, well, let's look at the pseudocode here, at least part of this pseudocode. So this pseudocode up here says, this is a little strange looking. It almost looks like it should be a function, but it's not a function. It's just some words that say navigate around wall. And then there's a block of some more pseudocode indicated by these curly braces. And inside that block, there's really only one if statement that says if we're blocked to the right, if we're blocked to the right. So remember what that means. That means if we can stick our hand out to the right, we will be touching a wall or a cliff or something. Okay, we're blocked to the right. That means there's something on our wall that will inhibit us or prevent us from turning to the right and going that direction. Okay, either a wall or a cliff. Now, navigate around the wall says if our hand, when we reach it out, touches something that means we're blocked that way, then we want to keep moving forward. Okay, so that ensures that our right hand is always going to be touching a wall or a cliff or something. Okay, we're going to be moving along forward as long as when we stick our right hand out, we're touching a wall or touching. Okay, now if for some reason our hand should come away from the wall, okay, like maybe the wall turns, or we somehow turned, then we need to get back to the wall or to get back so that we're walking alongside of it where it's on our right again. So to do that, we'll just turn right and move forward one. And hopefully at that point then, we'll be right next to the wall again. But if we're not, we'll go ahead and turn right and move forward again until we can find that wall that we were by before. Okay? All right. So navigate around a wall is just a simple procedure that just says, as long as we can reach out and we know there's a wall on our right, we'll move forward. If a wall is not on our right, then we're going to turn to the right and go find that wall so that we can again sort of catch up with it and have our right hand touching it again. Okay. We'll get back to this while loop in a minute here, but let's run this code. Okay, and let's watch what Byte does here. Okay, so there's a gem 2 squares over here to his right. He's going to walk around this wall and get to this gem. It looks like a good part of this puzzle is already solved. Now, he didn't collect the gem, but he did walk all the way around that wall. And it looked like he might be using this pseudocode algorithm here, where he kept his right hand, if he kept his right hand out, he'd be walking alongside, touching this wall on the right, and then up here on this square, he would no longer be blocked to the right. His hand would come away from the wall, so we know he has to turn to the right and move forward, where his hand would then be again touching the wall. Okay, so, and he ends up coming over here and his hand's not touched. He turns to the right so that he gets back to touching the wall on the right and then moves all the way down this path to get on this gem. So let's look at the Swift code here on what just happened. Okay, so there's a function up here, and we'll say it's going to be, the function is going to be navigate around wall. Okay, let's not look at the details of that yet. But navigate around wall in our main program, we're saying as long as we're not on a gem, we want to navigate around the wall. Okay, and that makes sense because he stopped as soon as he was on this gem. He stopped navigating around the wall. All right. So again, what is navigate around the wall? Well, this is just the Swift version of that pseudocode above, which says if we're blocked to the right, that's good. We want to keep moving forward. That means the wall is on our right. But if we've come away from the wall, we have this else statement here, which says we need to turn right, go back and find the wall by moving forward until we're blocked to the right again, and our right hand will be up against the wall. All right. So we're going to keep calling this navigate around wall function as long as we're not on a gem. When we're on a gem, we know we successfully found the gem. So at this point here, we know what needs to be true. We must be on a gem. We must be on a gem because this while loop keeps going as long as we're not on a gem. So if it stops after the while loop, we must be on a gem. So we can go ahead and collect the gem. Okay? So this is great. This sequence of commands right here, this while loop, which just says keep navigating around a wall so that our right hand stays on that wall, keeps happening until we're on a gem, and then we can collect it. So this whole bit of code right here, from here to here, its sole purpose will be to navigate around these walls and collect a gem. Okay? In fact, if we call this again, navigate around wall till we collect a gem, we'll get over here to this gem, I would think. But we might need to turn around first, right? We might need to turn around. So, okay, let's do a turnaround function here. We'll turn around, and I'm going to call this function func turn around. And it'll just be a turn right and a turn. Okay. Now at this point, if we were to call this whole thing again, presumably we'll be facing away from us. Presumably we will go navigate around this next block. Okay. This next wall until we get to this gem right here. Let's just try this over and over again a few times. So I am going to put this whole thing right here in a big loop itself. And I'm just going to say, while true, I want to keep doing this over and over and over again. While true, I just want to keep navigating around walls until I get to a gem. Then I want to collect it and I want to turn around. Okay, we're going to keep doing that over and over and over again. And let's watch what happens. Okay, here we go. Okay, this time the walls lay out a little bit differently, but this should work. We keep navigating around a wall with our right hand on it. If it's not, we move back over. Here we collect the gem and we turn around. Now we call navigate around wall again until we're on a gem. We're on it, we collect it, we turn around. Now we put our right hand out against the wall and we keep moving forward until we're not blocked to the right, and then we turn to the right. Until we're not blocked, then we turn to the right again and we put our right hand against the wall. We keep moving forward until we're on a gem, and we collect it and turn around, and we're going to call navigate around the wall one more time until we're on a gem. But this time we're not on a gem, are we? So he's going to keep trying to navigate around the wall, and that's because we have this while true in here. So what's a better condition to tell Bite when to stop? Should it be while true, or when do we know he's reached the end? You got ideas? Yeah, it's when he reaches that switch, right? So we can say while not is on a closed switch. While we're not on a closed switch, keep doing this, walking around walls and collecting gems. Okay? But as soon as we are on a closed switch, again, we know a condition that must be true after this is we know we must be on a closed switch. We would never get to here if we're not on a closed switch, because as long as we're not on a closed switch, we're going to keep navigating around walls and collecting gems. Okay? So we know we must be on a closed switch, so at this point we can just toggle the switch. Let's try running the code. Okay, we got a nice short wall here. We'll keep the right hand on the wall and navigate around the wall until we're on a gem, then we'll collect it. We turn around, we put our right hand, we keep moving forward along the wall until we're not on it, then we turn right and move forward. Here we're not on it again, we turn right, move forward. Keep our right hand on the wall, keep moving forward until we're on a gem, then we collect it, turn around. Here's a wider wall. As soon as our right hand is not blocked anymore, we'll turn right, move forward, turn right, move forward. Keep our right hand against the wall as long as we're blocked to the right. We keep moving forward, then we collect a gem, the short one. Now this time when we come down here, we won't be on a gem. He made it across all these first four walls, but then when he got to this last one here, he seemed to want to keep trying to navigate around the wall. So we have a logic error in our program, and let's try to figure out what went wrong here. So let's go back and look at our code. Now, our main program, it simply says, while we're not on a closed switch, we want to do something, okay? And I like this because he's on the closed switch right now, so he should have, when he found himself is on a closed switch to be true, when he found himself on this closed switch, he should leave this while loop and come down here and toggle it. The problem is he never got to the while loop here to check on this iteration if he was on the closed switch. So something must have happened in here where he got trapped in here and never asked if he was on a closed switch or not. So let's think about this a little bit. Now, what we said we want him to do when he's walking around here is to just keep doing this navigate around wall as long as he's not on a gem. Okay, so that worked fine here going around these four walls, but now it didn't work fine when he got to the switch, and that makes sense, right? Because he's not on a gem. And if he's not on a gem, he's supposed to keep navigating around the wall. Okay? So this condition inside the while loop, the as long as we're not on a gem, keep navigating around a wall, works fine as long as the thing that signifies him to stop navigating around a wall is a gem, and there are gems around to make him stop. But there's not a gem here at the end. So really what we'd like him to do is we'd like him to keep navigating around the wall both if he's not on a gem and if he's not on a switch. Okay, so we need to check for both those things. If he's not on a gem and he's not on a switch, then we want to navigate around the wall. But if either of those are not the case, meaning that he is either on a gem or he's on a closed switch, then we want him to stop navigating around. Okay. So as long as he's not on a gem and he's not on a closed switch, then he's going to keep navigating around the wall. Now, what happens when he is on a gem? Well, he's going to come down here and say, ask if he's on a gem, then collect the gem and turn around. And we know that works fine. Now, what happens if he is on a closed switch? Well, this will be is on a closed switch will be true. This not is on a closed switch will be false. And since both this and both both of these terms, not on a gem and not on a closed switch, will need to be true in order for him to keep navigating around the wall. They won't both be true because he will be on a closed switch. So he'll stop doing this while loop. He'll come down here and he'll ask, is he on a gem? No, he's not, because he's on this closed switch. So he'll not do anything in this if statement block. And he'll come down to the end where he'll come up to this while loop and he'll ask, well, you're not on a closed switch. Well, again, he is on a closed switch. So this will not happen again. And finally, he should come down here and toggle the switch. Let's give that a try. We'll run the code. And he's saying, as long as I'm not on a closed switch, I want to check if I'm on a gem or I'm not on a closed switch. If I'm not on a gem and I'm not on a closed switch, I want to just keep navigating around the wall. If I do end up on a gem, I'm going to collect that gem and turn around. Okay, so that's again going to keep working fine. He's navigating around the wall. Oops, now he's on a gem, so he leaves the while loop and he collects the gem and turns around. Now he does it again because he wasn't on a closed switch. Okay, coming around the wall, finds himself on a gem. He leaves that while loop, collects the gem, turns around, keeps going on with the outer while loop, which says as long as he's not on the gem, he wants to keep navigating around the wall and checking if he's on gem or closed switches. Now here he comes and he will be on a closed switch, so this while loop will be false, and he'll leave the while loop and he'll come down here and toggle the switch. So good. We solved that puzzle. Now there's another modification we can do to this a little bit if we want to, and it's worth thinking about. It's always worth thinking about if you like a different way, and you may find you like this way, the way we did it the first time, or you like this new way that we're going to talk about here. So if we really think about this, if we think about this a little bit, we could think about this a slightly different way. This is always going to be the way we need to work here. We're always going to say, as long as we're not on a closed switch, we want to do something because the closed switch is indicating when we're done. So we know we want to stop doing this set of commands when we are on a closed switch. So that's going to stay the same. Now, what could be different in here is getting rid of this. And let's ask ourselves, when do we want to navigate around the wall? Well, we kind of always want to keep navigating around the wall, except in one case. And that one case is if we're on a gem, right? If we're on a gem or we're on a closed switch or something like that, then we don't want to keep navigating around the wall. So as long as this while loop is in here, though, as long as this while loop is in here, we can just maybe say, as long as we're not on a closed switch, let's just keep navigating around the wall. Or actually, we can just do something like this. We can say, if we're not is on a gem, we're not is on a gem, then we just want to keep navigating around the wall. Okay? If we are on a gem, though, if we are on a gem, then we already know what we want to do, and that's this stuff in here. We must be on a gem, so turn around and collect that gem. Okay? So let's go ahead and move this code up into there. There we go. And let's think about this now. So we got rid of that inner while loop because we always want to keep navigating around the wall unless we're on a gem or we're on a closed switch. And we're checking here if we're on a closed switch, we'll stop. And now we're checking here if we're on a gem, we'll stop and do something else. Okay? Too much? Okay, so let's just maybe think about this for a minute. As long as we're not on a closed switch, we want to check. If we're on a gem, no, we're going to navigate around the wall. This won't happen because we're not on a gem. So we'll come back up to here again, and we'll say we're still not on a gem, so we keep navigating around the wall and so on. Okay, so this is a little simpler maybe than our last batch, but let's just check and make sure that everything works out all right. So let's step through the code one more time. While we're not on a closed switch, we're going to ask, are we on a gem? If we're not, we're going to navigate around the wall. Most of the time, we're not on a gem. So we're just going to keep calling our navigate around the wall function. Run it a little faster. And there, when we are on a gem, this S statement will happen where we'll collect the gem and turn around. Okay, here we go. Keep going. Still not on a closed switch, so he's navigating around the wall. And finally, we are on a closed switch. And when we're on a closed switch, we're going to no longer do any of the checking if we're on a gem or navigating around the wall and so on. We're going to come down here and toggle our switch. So two different ways to do this. It's up to you which you like better. One has the nested while loop in there. This one doesn't have the nested while loop in here, but it's essentially doing the same. Okay, just to review here, we have this right-hand rule, which remember, we're just basically saying we can navigate around a wall as long as if we outstretch our right arm and we're touching the wall, we just keep moving forward. And if we're ever not touching the wall with our right hand, we want to turn to the right and get back to the wall as soon as possible. So we use that simple algorithm to build this more complex thing, which lets us navigate around all these walls and get to the closed switches. Okay? All right, this is getting a little tricky, so don't worry too much about this. If you didn't get it right the first time or if ever you got stuck, not a problem. Not a problem. Just watch how I did it here. Take again, just like we've done in the past, take a couple days off, come back to it later and try to build it yourself again. And if you still get stuck, watch the video again and try it again 2 days later. Okay? All right, keep it up. Good work, everybody. See you next time.